right, so today we're going to look at isosceles triangles. We're going to just focus on isosceles triangles. Is our plan, which is our last lesson for this unit before our test. Yay! All right, first of all, what is an isosceles triangle?
Two sides are equal.
Two sides are equal, right? A triangle with at least two sides equal, which means you could have more than two sides equal, and that would be okay. Okay? So, a triangle with at least two congruent sides. So it might have three congruent sides, but it for sure is going to have at least two congruent sides. Okay? All right, so then what I want to do is on step 2, it says to, in the space below, construct an isosceles triangle. Okay? In the space below. It's kind of redundant, but that's okay. All right. Be sure to use a ruler so that you can be sure that the two side lengths are equal. So it really wants us to be sure because it says be sure twice. Okay? So be sure to use a ruler so that you're sure that the two sides are surely equal. Yes?
Sure.
Okay. You can measure whichever you like better, centimeters or inches. It doesn't matter here, really, not at all. But you're just going to pick, and everybody, we can all make different sizes. It doesn't matter. I'm going to go with 8 centimeters. So I'm just going to, from here, from the 0 out to the 8 centimeters. So if one side is 8 centimeters, then my other side also has to be 8 centimeters. So I'm just going to come over here, and I'm going to make it also from the 0 out to 8 centimeters. The more accurate you are, the better this will work for you, as with most things we do. If it doesn't work out, then off to the side, you just say, not to scale. Okay. So both of those are 8. Remember, we show in math, in geometry, when two segments have the same length, we can add tick marks to them. So this side is the same length as this side. Okay. And so then here is my bottom section, or my bottom piece of my triangle. Alright, so there's mine. I kind of made mine obtuse. You could have made yours however you wanted. Now, depending on your angle that you opened your two sides up at, even if you also did 8 centimeters, you may or may not have the same length. I'm right at like 12.8 centimeters along the bottom. You might not be the same length, and that's okay, as long as it's isosceles. As long as two of your sides are exactly the same, then you're going to be okay. All right? So, then the next thing we're going to do, it says, on the triangle you just drew, label the following parts. So the first thing I want to label are the legs. And it tells me that the legs are the congruent sides. So the two sides that I marked with the tick marks congruent, those are the legs of the triangle. So that's a leg, and that's a leg. For me, they're both 8 centimeters. Yours might be different, and that's okay. All right. Then I want to label the base, and the base is the third side, which usually in most isosceles triangles is different unless it's an equilateral triangle, and then it would be the same. For me, it's a different one. But this down here is my base. Okay? Then after the base, it says to label the vertex angle, and that's the angle where the congruent sides meet. So if I look at my congruent sides and I were to trace them with my fingers, where my fingers touch each other, that's the vertex angle. So this one up here is my vertex angle. Okay. And then last but not least, we're going to label our but that's not where I wanted to put it. We're going to label our base angles. And the base angles, it says, are the angles at the base. So they're kind of like the feet to the legs, right? The legs come out of the vertex, and they're like the feet. So this one is a base angle, and this one is a base angle. I'm going to go close the door real quick. Pardon. Now it's not so distracting. Okay, so we got everything labeled. Number 4 says use your protractor to measure the 2 base angles of your triangle. And then what do we notice about that? So I'm going to use a protractor. Remember how to measure with a protractor. You need to line up the line along the bottom of your protractor with one of the lines on your triangle. I'm going to line mine up with the base. And then you slide it over to one of the base angles, right? So that the base angle is right there at the center. And then we're going to look and see how open it is. Now, we all drew different triangles probably, so ours are all going to be different. But we do want to look and try to see how big we think they are. So mine, remember there's 2 sets of numbers that we're opening. Okay? So you look out and you see where the 0 is. Those are the numbers you're going to be looking at. So here's the 0 for this one. So I'm using the inside numbers 10, 20, 30. I'm open a little more than the 35. It looks like I'm at to me that looks like 36.5, like right halfway between the 36 and the 37. So for me, I'm going to say 36.5 for that base angle. Then I'm going to go measure the other side. Which is a little harder because of the way the paper lines up. But when I look at that one, and I have it lined up, that one, it's pretty darn close to the same, right? Yeah. When I have that lined up. Remember, this time we're using the inside numbers because here's my 0, 0, 10, 20, 30. So we're using the outside set of numbers. We're not going to start at 180 and count down. So this one's also, for me, 36.5 degrees. Did anybody else find that theirs were also equal, or is that just a weird thing that happened with me? Huh?
Mine is 1 degree off.
1 degree off, so it could just be maybe our lengths are a little bit off on both of them. Did anybody get drastically different angles? Huh? So my question is not, did you get a different angle than me? Because we should have all gotten different angles. None of us drew the exact same triangle unless that's just weirdly happened.
I got 41 degrees.
On both sides?
Yes.
Good. Did anybody get drastically different angles on their 2 sides? Like get a 41 on one side and a 32 on the other side?
No.
Everybody got within a degree or 2?
Yes. 5.
So if you're more than a degree or 2 off, you might want to go remeasure the 2 sides or remeasure the angles, because either your 2 sides aren't the same or your angles, you didn't measure the angles correctly. Okay? Because what do you think we're noticing about the 2 base angles on an isosceles triangle? They have the same measure. Or equal measures. They have equal measures. So if they have equal measures, then guess what that means? They're congruent. So what does this mean about the base angles of an isosceles triangle? Base angles in isosceles triangles triangles are congruent. Base angles in isosceles triangles are congruent. Okay? So, it's going to be really helpful anytime we're working with isosceles triangles, if you're in Schoology, to have scratch paper so you can sketch it, so you can label it where the base is, because you know those two angles along the base are going to be equal, and you can add tick marks if they're not already there for the legs. Okay? So, for example, when I look at these example problems, when I look at number 1, I can see the two sides that have the tick marks. Okay, so I know this is a leg, and I know this is a leg, which means this is my base, and the two angles that are touching the base are equal to each other. So if one side is 3x, that means the other side is 3x. Well, what did we find like 2 weeks ago when we tore the three angles off the triangle and we put them together? What did we find they made? 180, right? So I know if I take these three angles together, they're going to make 180. So 3x plus 3x plus 90 has to be 180. What's the first thing I should do?
Combine like terms.
Combine like terms. So 6x plus 90 equals 180. Then what?
Subtract 90.
Subtract the 90 on both sides. So 6x equals 90. Then what? Divide by 6, and what does x equal? 15. Okay. You could also just do some reasoning on this problem. You could say, well, if I've used 90 degrees here, I know out of my 180 there's 90 left. And those 90 degrees are evenly distributed here and here, right? So if they're that 90 degrees is evenly distributed, both of these have to be 45. So I know 3x has to equal 45. 3 times what makes 45? 3 times 15. So that one you could kind of just reason through if you'd like to. Okay? Yeah. All right. Next. All right, this one, I don't see two sides marked congruent, but I do see two angles marked congruent. If I turn my paper sideways, I can see that both of those angles touch segment ST. So that means those are congruent base angles. ST must be a base. Which means these are my two congruent legs. So your isosceles triangles, even though it has a base, the base isn't always the bottom. Sometimes it's rotated all kinds of ways. Okay? How can I solve this one for x?
Write both equations equal.
Write both equations equal to each other, because this leg equals this leg. 3x minus 6 equals 2x plus 6. What do you want to do first? There's 4 options.
Add 6.
Add 6. If I add 6 to this side, it's going to cancel with the negative 6. When I add 6 to this side, I get 2x plus 12. Okay, now what?
Subtract 2x.
Subtract 2x. If I subtract 2x from this side, I'm left with just 1x. When I subtract 2x from this side, I've got 0 plus 12, which is just 12. So x equals 12. All right. Number 3. Which one, MN, NO, MO, is my base? MO is my base. MO is my base. Do you see something wrong with how this is labeled? I just noticed there's a problem with how it's labeled.
Not capitalized.
My M here is not capitalized. Your corners of a triangle should always be capitalized. Okay? Huh? Okay. So that should be capitalized. But MO is my base because it's where the bottom of the two legs. This is a leg because it's congruent. This is a leg because it's congruent. Okay? So those two angles that come up out of the base we know are congruent, so they're both 5x. So I can say 5x plus 5x plus 90 makes 180. What's the coefficient on x when I combine my like terms? 10. All right, what should I do next?
Subtract 90.
Subtract 90, so 10x equals 90. So what does x equal? 9. Again, that's another one you could just kind of talk yourself through it, right? That's another one where you could say, oh, I know 90 is at the top, so there's 90 left for the other two, so 45 on each side. 5 times what makes 45? 5 times 9. Okay? That'll always work when you have a 90-degree angle up there at the top. If you have something else, you have to do a little just more thinking is all. Okay? All right. Next, number 4. So this one's a little bit more challenging. Which one, A, B, AC, or BC is my base?
AC.
AC is my base because the two with the tick mark are the legs, leg and leg. So this is my base, which means angle A and angle C are both 6x plus 6. And then that top angle is 2x. If I add those three angles together, they equal 180. So 6x plus 6 plus 6x plus 6, so that's angle A and angle C, plus the 2x at the top. The three angles equal 180. When I combine all my like terms, how many total x's will I have? 14. And my constant? 12. Equals 180. What do I do next?
Minus.
Subtract 12, so it cancels out on the left side. And on the right-hand side, 180 minus 12?
168.
Then what do I do? Divide by 14, and x equals 12. All right. Next. All right, I've got PRQ. Which one is my base? RQ, because this is a leg and this is a leg, because they're marked congruent, so that means this is my base. So coming up out of my base, those are both 2x. So when I add them together, I'm going to have my 40 plus my 2x plus my 2x equals 180. 40 plus, how many x's? 4 x's equals 180. When I take away the 40 on both sides, I'm left with 4x equals 140. When I divide by 4, what does x equal? 35. So this one, if you wanted to just think through it logically, you'd say, oh, I've already used 40 degrees for that vertex angle. So that means there's 140 left. If I divide 140 into those bottom two angles, each of those angles has to be 70. So 2x equals 70. So x has to be 35, because 2 times 35 makes that 70-degree angle. Okay. Number 6. Which one's my base? RS, because here's a leg, here's a leg. So this is a base, which means the two angles that come up out of the base are my congruent angles, which means they're both x. So x plus 3x equals 180. How many x's do I have?
5x.
5x equals 180. How big is x?
36.
36. Okay. Alright, and then my last one here, number 7, find x and the length of each side. What do you think I should do?
Put the congruent sides equations equal to each other.
Good. Put the congruent sides equal to each other. What I want to remind you is to be real careful, because a lot of people get this one and they go, oh, if you take the 3 parts of the triangle and add them together, they make 180. That only works for what? Angles. Angles in a triangle add up to 180. Sides of a triangle don't add up to 180. They add up to a perimeter. And that perimeter can change from triangle to triangle to triangle. It's not always the same, right? So remember, your angles add to 180. Your sides add to a perimeter, okay? So I can't just add these 3 things and say, oh, that makes 180, because these aren't angles, these are sides. But I can see I have a tick mark here, and I have a tick mark here. So I know these are my congruent legs. So I know those 2 things equal each other, okay? So 3x plus 7 is going to be equal to 2x plus 20. What do you want to do first? There's 4 options.
Subtract 7.
Subtract 7. So if I do that, I end up with 3x equals 2x plus 13. Okay, now what?
Subtract 2x.
Subtract 2x. So when I take away the 2x, I'm left with x equals 13. Okay, so now I know what x is. It says to find the length also of each side. So I found x, but I still have to find each side. So when I look at this side here, my 3x plus 7, and x is 13. 3x plus 7, or 3 times 13 is?
39.
39 plus 7?
46.
46. So this leg is 46, which means the other leg is what?
46.
46. But it's good to just put it in and just make sure, right? 2 times 13 plus 20. 2 times 13 is?
26.
26 plus 20?
46.
Is 46. So that makes me feel, whew, I did my math right. They're both 46. And then last but not least, I need to find that last side, the x minus 4. But we know x is
13.
13. 13 minus 4 is 9. And so you can see 46 and 46 and 9 are definitely not going to make 180. So if you would have set them equal to 180, you'd have gotten the wrong answer. Okay? One other thing, sometimes you'll get a picture like this and it'll also have a tick mark here, so all 3 will be the same. If you're ever given an equilateral triangle and you have all 3 sides and it says to find x and each side, you can pick any of the 2 sides you want and you can set them equal. So you can do these 2 equal each other, these 2 equal each other, these 2 equal each other. I usually just go with the 2 that have the smallest coefficients, so I get to work with smaller numbers. You can pick whichever 2 you want, and then when you plug in your x, it should give you all 3 sides would be the same. Okay, questions? All right, your assessment for today is in Schoology, and that's all I have for you.